good afternoon. Happy Saturday. As always, we start our streaming with some algorithms, so let's go ahead and get into some algorithms. Alright, so we're going to do some 8Q, and then we're going to do one LeetCode easy, and then we will get started on doing some AI agents roadmap. This is done with roadmap.sh, and I love roadmap.sh. The reason why is all of these are basically like any way that you want to go ahead and learn. Say for instance you want to go ahead and learn Python, it's going to go ahead and teach you basic syntax, go ahead and show you some other stuff. It's a good roadmap to go ahead and show you fundamentals of what you need to learn before you go ahead and get started on everything else. Yeah, I think this is all a good framework. So for whatever you're looking for, if you're like want to become a Python developer, or I saw that they have Power BI now, which is pretty cool. So they have a lot of these other great options as well. Yes. Well, AWS would be kind of cool to learn. I've been seeing a lot of like resume applications where they're asking for AWS. So yeah, but before we get there, let's go ahead and get started with our AQ. So every budding hacker needs an alias. So the Phantom Freak, Acid Burn, Zero Cool, Crash Override are some notable examples from the film Hackers. So your task is to create a function that given a proper first name and last name will return the correct alias. Two objects that return a one word in response to it. If the first letter given to the function is not a letter from A to Z, you should return your name must start with a letter from A to Z. The first character are either names. Sometimes people might forget to capitalize the first letter of the name, so your names should go ahead and accommodate for these. So you need an alias. So given a proper first and last name, you're going to go ahead and return an alias. Okay, well my question to you then is, okay, so given that we have an input of Mike and Millington for the last name, first name and last name, how did they know to go ahead and do, malware Mike? Let's see. Okay, one thing for sure. Okay, so we're gonna receive a string for first name and last name where first character is capitalized. So now you're gonna return a first name and last name nicknamed. So say for instance I put in Mary for first name and then Barry. I can expect like malware. What's a good thing for B? Beta. Based on the examples they have here. My question is, how did they get the nicknames? I don't know how to get nicknames. Do you get a list, or do I just say, hey, randomize this and give me a different nickname? How do they get a nickname? Sometimes you forget. So these two, okay. So the dictionaries are already preloaded, so you can just use them in your code. A is for alpha, and then for first name, last name is A is analog. So okay, so based on what that stated, I don't know what M is over here, but if I had the initials of like Amber Andy for last name, it'll be alpha analog is going to be what's returned. So they already gave you some nicknames there. Okay, but some edge cases to think about, as I stated earlier, that if the first character of each name is not a letter, then we have to return you have to return this. Otherwise what you're going to do is also, if the first name is not not capitalize, go ahead and so uppercase the first character, match it from the first name, and also match it with the last name. Match the character from first name, first char, and return that as first nickname. And you're gonna match the character and do the same for our surname as well. Do the same for surname as well. And you're gonna join the two names together. So what I anticipate to go ahead and see is that if f name of 0 is alpha, not alpha, is basically saying, is it alphanumerical? Is it an alphanumerical letter? I want to make sure it is alpha Python. That's basically saying, hey, if you are a alphabetical letters, yes, perfect. If you are not alpha, meaning saying, hey, if you are not alphabetical, we're gonna return or L name of 0 is alpha, or then we're gonna return your name will start with that. Otherwise, we're gonna say that we're gonna say that f what's the word? F name, first name here is saying, hey, F, return me the first name of F name of 0. This should be able to go ahead and give me the first letter in the character, and then we're going to say dot lower, dot upper, and we're going to capitalize it, and then it's going to go ahead and find me that value attached to that key. And then last name is equal to alpha surname of L name of 0 dot upper. We're going to return first name plus last name. And let's go ahead and run through this. Okay, so say for instance I get A as my letter. I'm going to go ahead and say, hey, I don't know if it's capitalized or not, but just to go ahead and be I don't know if it's uppercase or not, but a way to go ahead and ensure it is uppercase, since all of my keys are uppercase in the first name objects, I'm gonna go ahead and capitalize it, and it's gonna find me the capital letter A, and it's gonna return me back the value, which is alpha. Same thing goes here for L name as well. If the last name is A, it's gonna be capitalized, and it's gonna look at and return back at the key, and it's gonna look back at the return me back the value. So it's gonna return me analog. So first name, last name, first name. It is plus. Alright. Or you could definitely do a try. You can try doing this. Say we're gonna uppercase it and then find me the first letter. Or you can go ahead and capitalize everything. Dot upper. I want to make sure dot upper is capitalizing everything. Yes. But I only care for the first letter. Otherwise, you can do that. You know, I should probably do the format too as well. That was good. Okay. I want to do, then we're going to do one more of some neat code. Neat code 250. Courses, not courses, practice. We're going to do neat code 250. I'm going to go ahead and choose random problem. Let's do this. I don't think it'd be we'll figure this out. So you're given an integer n breaking into a sum of k positive integers where k is greater than or equal to 2. And then you're gonna maximize the product of these integers. Return the maximum product you get. Okay. 12 at 3. Okay, let me think about it. So you're gonna receive an integer, and you have to return the 12 plus 3 max product you get. So we have to multiply. Product is always about multiplying. So n equals 4. So you're giving an integer of 4. You break it into the sum of k positive integers. Break it into the sum, and then so you're gonna say, hey, I iterate. So for 4, what I would do is iterate up to 4, check the even numbers. I would, where k is greater, break into the sum of k positive integers. Where k is greater than or equal to 2, and maximize the products of those. But my only concerns are break into the sum of k positive integers. Okay, I get it. Okay, because I was like, wait, positive integers. I'm thinking like, hey, it needs to be positive integers. So the second example didn't make sense to me. 3 is not a positive integer; it's an odd number. But what you needed to do is make sure that you get this n. For the end, you have to divide it by a certain amount of number to get a positive integers, and you always have to make sure that it's greater than or equal to 2. Say for instance, if n is equal to 2, you can still do that. If n is equal to 2, you are able to go ahead and get 2, but 2 times 2 plus what and 2 plus 2 times what is equal to 2. I think the max you can do for 2 is just 2. And so what you need to do is not iterate up to 4. You need to find 12 mod something. You need to take the output divided by something to get an equal amount of numbers. Because we took 12 divided by 4, which gets us to 3. 3 times, and you get 3 times 3 times 3 times 3, which is 4 amount. 4. Okay, so what I think about is we're gonna take, because you don't know, as of right now, I don't know what the even number is. So we're gonna take the output divided by each individual even numbers. We are gonna check to see. Then you're gonna check. So for each individual number, 12 divided by 12, 12 divided by 1, 12 divided by 2, 12 divided by 4, 12 divided by 6. And you're gonna try to maximize the product of those numbers. The reason why 12, because you can do 12 by 2, and it's 6 times 6. Sorry, not 6 times 6. 12 divided by 2, yeah, 6 plus 6. So this is 6, where 6 plus 6 plus 6. 12 divided by 6, which 12 divided by 6 is 2. Gives you 6 times 6 plus 6. 12 divided by 2. 12 divided by 2 is equal to 6. Yeah. But if you take this output, 12 divided by 6 is 2. So you do 2 times, is 12 divided by 2 is 6. So you do 6 plus 6. But then this one is 2 plus 2 plus 2 plus 2. 1, 2, 3, 4, 5. And then 6. But if you do 2 times 2 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16, 16 times 2 is 24, 24 times 2, this is equal to 48. As you can see right here, our max right now is 81, 6 times 6 is 36. As you can see, 81 is the max product that we've seen thus far. So we will have to try all even numbers and making sure we will have to try all even numbers all the way until 2, 4, 6. 8 doesn't go into 12. We want to make sure they're whole numbers. And then the last one I can think about is like 12 divided by 12, which is 1. 1 plus 1. But ultimately, 1 times 1 times 1 is still just 1. So we're not going to go there. So that's why 81 rings top, because 81 is a max product that we've seen thus far. Okay. We're going to check to see... We're going to check to see the quotient. It's not quotient. But we're going to check to see that this output, the output, multiplied by this, the divisor, I believe it's called divisor. I'm not too good with the mathematical terms, so bear with me on that stuff. So the divisor. And then we are going to check to see if output times divisor is greater than what our max is. If so, update our max. This is what I'm thinking thus far this is going to be used for. In this particular instance, there are no specific patterns I see. I don't really see like any 2-pointers. I don't really, not yet, or sliding window, or 2-pointer sliding window, or any frequency count or anything like that. Nothing in particular yet about this. Okay. So we're going to initialize our max value to equal float negative infinity. We're going to say negative infinity because that is the smallest that we'll get. So we're going to go ahead and say that for num in range, starting at 2 all the way until n plus 1, we're going to go by 2. We're going to say, hey, if n divided by the num is equal to 0, if n divided by num is equal to 0, n num, if n divided by num, because I'm saying, hey, give me 4 and divide it by every even integer. If it's a clean 1, good. Okay, I'm glad to hear that it was a clear direction. I was thinking, because I wanted to make sure that I can spot any patterns, and I'm glad that it was just like regular math and that I was like, I didn't see any other suitable patterns for it. Okay, good that I can notice that. So otherwise, if n divided by num, so we're saying here that, hey, if we say for first example is 4, 4 divided by 2, if that is equal to 0, then we're going to take, as we did here, we're going to take 3 times that amount. We're going to take our output times the num integer that we're on. Then, did I break it? I want to indent. Then we're going to say, n, I think it's called divisor. Please correct me if I'm wrong. So n minus num, this is going to be our 3, n minus num, and then we're going to say divisor times by the num here. How many times did it show up? This is going to be our value, and we're going to say max value is equal to max value or max value. Because let me walk through it to return the max value seen. Okay, so what's going to happen here is, say for instance, let's walk through example 2. So n is equal to 12. So here we're going to say go all the way to 12 and skip by 2. So we start at 2. Right now we're going to say 12 divided by 2 is equal to, if n divided by which is always going to be 0. Because if I go by even numbers, they should always just be just to be safe. I don't know if there's going to be odd numbers, but we're just going to go based off of this. But 12 divided by 2 is equal to 0. It's a clean whole number that we know that it's going to be a good number to go by. And 12, then now we're going to say, hey, 12 divided by 2, what do we get left over? 6. Then now we're going to say, hey, 6 times 12. Or 6 times 2, because our num right here is currently on the 2. 6 times 2. This is going to say 12. Okay, thus far, we have seen 12. And now we're going to go here. We're at 4. We're at 4. You know, okay. I am not going to say we're going to go by 2 because we need to try all of the numbers instead. So we're going to start at 2 for sure because k is always going to be greater than equal to 2. That's why I feel comfortable with it. So now we're going to go to 3. If 12 divided by 3 is equal to 0, which is true, we're going to say, hey, we're going to say 12 divided by 3, this is equal to 4. And now we're going to say 4 times 2, sorry, not 4, 3 times 2. Okay, I see where it went wrong. Okay, so I thought it was going to be 3 times the num, but it's not going to be. It's 3 times, it should be 3, num should be multiplied by 4 times. So this one should say, because this one is saying right now 4 times 2. This right now is saying, hey, 4 times 2, or 4 times 3. This is saying because the divisor that we have left is 3, as you can see right now. But based off the example, it should be 3 times 3 times 3 times 3. I'm trying to think of a way to do that. What I could do is probably do like a while loop. You could do a while loop to calculate that. That while divisor is greater than 0, we're going to keep subtracting for divisor until it goes. But that's a lot of work. But that's what my mind is thinking about right now. Let me just go ahead and... While divisor is greater than 0, we're going to say, hey, take the num. We're going to say, take num, or total. We're going to say total right here is equal to 1. Total times equal divisor. Or sorry, num divisor minus equal 1. So this one, I am anticipating, I might be over complicating it. And let me know what your thoughts are too. But I'm saying, hey, while the divisor, this is 4, then we're going to take 3 times 1 is 3 times 1 is 3, and then now 4 becomes 3. So this one becomes 3, and then we're going to say 3 times 3, and then now, then total, this is actually total. Wait, we run it here, because total is going to get, it's going to go ahead and go off and do its thing. Go ahead and calculate, and then after you're done calculating, we're going to exit this while loop. Then I want to go ahead and look at that total. I feel more comfortable. I was like, I feel more comfortable with that, but that didn't work. Your output was negative infinity, but the expected return is really max value. If I say negative infinity, then I know that it's going to be greater. I thought total would get updated. Print is total. Nothing. Print total. Nothing? No way. Print total, no way. I wonder. Did I print a wizard? Okay, something. What if you don't hit the if condition on line 9 for any of the value in your loop? 19. Well, if you don't hit the if condition on line 19 for any value in your loop, that's a good question. That is true, because I always just assume everything is going to equal to 0. Okay. Else? That's a good question. What I would anticipate for line 19, if nothing hits that, then I'm going to say, hey, we're going to continue. Let's go on to the next number, because we know we're not going to find anything. That's what I'm... in my... yes. Thank you. And yes, line 19... because, yeah, I'm checking the remainder. I want to make sure that it's... Hi, hello. Thank you for stopping by. You have n minus, which is never 0, unless n is equal to 0. Yes. Okay. Thank you for correcting me on that. I was like thinking I need to look at remainders, but I don't need to look at remainders. Okay, so if n mod num do this, else something's gonna have a remainder, then I just want to say continue. Is that why it didn't work, Betsy MP? I just forgot to go ahead and tell it to continue. Is that why? So thus far, with everything that I'm doing thus far, I do the iterate through the entire... I iterate starting at 2, go all the way until n. No, you're not distracting. Yeah, you're not distracting at all. K Martinez, I really like Necode. I love Necode 250. I do think that Blind 75 is a good place to go ahead and get started, but Necode 250 is a good other area to think about. I did like a leak code the other day with like strings and characters, and I didn't know how to tackle it, but I found that Necode 250 had like a similar problem in theirs, and I'm like, I guess I'm used to Blind 75, so. But I would recommend Necode 250 after you're done with Blind 75. I would definitely recommend that. Yeah, I love Blind 75. Yes. Blind 75 is a great way to go ahead and start, and after that, go to Necode 250. That's what I would recommend. Yeah, so for number range, this one is iterating through every number starting at 2, so it's going to be O of n. Oh, yes, it is. Where is it? Yes. So there's a Blind 75, a Necode 150, and a Necode 250. Yeah, I definitely would recommend the Necode 250 if you're looking to go ahead and branch out. And then, we're doing another while loop. We're only going up to whatever divisor is, so it's still going to be O of n. And overall, time complexity, worst case scenario, is still going to just be O of n. And I'm just trying to think about this, if there's any way I can go ahead and optimize this. I'm trying to think about like any redundancy that's going to occur, because I'm trying to think about any redundancy that's going to occur, and on top of my head right now, I don't think I see any redundancy, because if I do see redundancy, I would go ahead and take I'm thinking of like doing a key value, storing the key, having a key, and storing what the value that I got at that time. That's what I would think, but I haven't seen anything. Run. How's your Saturdays? Hit push. Okay, now it broke. Okay, let's figure this out. N is equal to 2, your output is 2, but expected output should have been just 1. But you know, I think 2 is a special case scenario. So if N is equal to 2, we're gonna return a 1. Oh, you know what? If N is equal to 2, I think it broke because I didn't start off at 1. That's why it broke. No, wait, okay. It's not the case. I feel like... I want to see if... I think 2 is a special one-off case. Let me know what your thoughts are, but I think 2 is a special one. Okay, no, it's not a special one-off case. Okay, hey, let's take a look at this. Why didn't it work? I'm still gonna go with 1. Okay, let's take a look as to why it didn't work. 10 should have been 36, but I got 32. Let me think. 10. Let's walk through 10 quickly. 10 divided by 1 is 10. 10 divided by 2 is equal to 5. 10 divided by 3, not good, because it has a remainder. 10 divided by 4, nothing. 10 divided by 5, this is equal to 2. Greater than 0. 10 divided by 6. 10 divided by 6. 10 divided by 7. And then 10 divided by... I'm missing a 4. 10 divided by 8. And 10 divided by 9. And 10 divided by 10. I'm thinking about the iterate all the way up to 10. And if we're looking at numbers that give us a good, very good, with no remainders, I would look at 10, 2s, and 5. 6, 7, 8, 9. Just making sure. 6, 7, 8, 9. I know that will give us remainders. 10 out of 10 will give us a 1. 10 divided by 10 is 1. Let's see. But if you do 10 divided by 1, 10 divided by 1 is 10. And you're going to say 10, but this one is going to be 5 times 5. This one right here. Five times 5, this is 25. Because you want to go up to just this amount. Right here, this would be 2 times 2. How did you get your 36? 3. Two times equal none. Total How did 10 get to 36? 10 divided by 1 is 10. 10 divided by 2 is 5. 5 times 5, this is equal to 25. This gives us a remainder. 4 gives us a remainder. 5. Okay, I get it. 2 times 2 times 2 times 2. 2 times 2 is 4. 4 times 2, 8. 8 times 2, 16. 16 times 2, 16 times 2, 16 times 2, I got 32. This is 32. 1, 2, 3, 4, 5. 2. No, but 32 times 2 will be way too much. Because we had 2 times 2, because we had 2, and we did multiply it 5 times. 1, 2, 3, 4, 5. 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. 16 times 2, 32. 16 times 2, 32. But they got 36. How did they get 36? I'm short by 4. Am I not reading the question right? If you're given an integer n, break it into the sum of k positive integers. Okay. It's sum of k positive integer. But 2 times 2 is 5. But we need it to be positive. We need it to be positive. 1, 2, 3, 4, 5. This is 5. So you're divided by 2, but 32 times 2 would be 6. 32 times 2 is 4. 64. Well, let's see. Ew, this was a dynamic programming? Ew. Okay, so if it's dynamic programming, it kind of makes me think about recursion. It kind of makes me think about recursion. Is there a way we can use a recursion here? I'm thinking like Fibonacci. I'm trying to think about like Fibonacci. Fibonacci is about like taking like fib of n minus 1 plus n of minus 2. That's what I'm thinking about for integer break. I'm thinking about Fibonacci. Break it into the sum of k positive integer. If you are an integer n, break it into the sum of k positive integers. And maximize the product of those integers. For 10, I don't think I can. Let me see suggested fix. Please upgrade Pro for more. Okay. Let's see. I really look at the solution. I think I've been at this for a while. And it was a dynamic, so I suspected to do a recursion. And I wonder if num is equal to 1, return 1. Return 0 if num is equal to n else num. For I in range, is you do a DFS. No, I would have never gotten this. Okay. DFS and num. No, I would have never gotten this. I know that with dynamic programming, typically you do like recursion, and I was thinking like Fibonacci, and it is similar almost to Fibonacci. Stop. You just multiply it by 3 for small values while handling them as special cases. But to break the numbers into many threes is possible. That's because 3 maximizes the product per unit. We would be leaving a remainder of 1. I didn't realize 3 was special. I thought I was calculating it right. No, I would have never got into this. I had the idea of being able to solve the smaller solution. I think this would be a good one to come back to. But I would love to go ahead and do some roadmap.sh with you today. So what this is, we're going to go ahead and learn some basics. We're going to go ahead and learn some basics. I want to see. Okay, let's do some quiz first, making sure that we understand what's going on before we move on to the next level. I have some ideas. Oh my goodness. Okay, I have some ideas about REST API knowledge that we can go ahead and get started. And please feel free to go ahead and chime in, and let's work on this together as well. So in the context of AI agent architecture, what is the primary role of REST API? In the context of AI agent architecture, sometimes when I do like sometimes when I work on these quizzes, sometimes when I work on these quizzes, I like to go ahead and do a process of elimination. The things I know for sure it couldn't be, that helps me get closer to figuring out what the answers are going to be. So I hope this will help you as well too. So I'm not too sure about the context of AI agent architecture, but what is the primary role of a REST API? It's to go ahead and replace the internal reasoning. I don't think so. Facilitate communication between the agent and internal systems for data exchange. This seems more like it. No, I don't think I'm multi-streaming. Feel free to let me know if I am. No, I wish. Okay, I was trying to connect and do that, but I'm doing it via OBS, and OBS like hated it. So let me know if you know any tricks on how to fix that. I would love to do that. To manage the learn time episodic memory storage directly in the vector database to serve as a high performance replacement for. No, well, technically, when you think about REST APIs, I think about like talking and communicating with other. Oh no, not at all. No, yeah, I was talking like in regards to, yeah, let's definitely work on this together. Like, yeah, partner programming and figure this out too. Let me know what your thoughts are as well for figuring this out. Have you learned a lot about AI agent? Okay. Okay, so you and I are on the same path. That's good, because if I think about like REST API, I don't think it's too much difference for AI agent architecture, because definitely, yeah, no, it threw me off a little bit, because I was like, wait, do they really treat it that much different with REST API? But yeah, for sure it's communication. We're gonna find out. Yes. Okay, option 2 is correct because REST API serve as the architectural bridge, allowing agent to retrieve external data, send outputs, and interact with third-party services, which is essential for extending an agent's utility. Okay. Oh, I thought I did, but going forward, I definitely will. K Martinez, yes. That's what I thought too. Yeah, that's what I thought too as well, Betsy MP. So, okay, let's go on to question number 2. Which HTTP method is most appropriate for an AI agent to send data to an external system to trigger a new resource creation, such as adding a task to a project management tool? Get, options, post, or head? For sure, not get. Get is basically saying like you exist already, and I'm gonna go ahead and get you so that I can read your information. I've never heard of options. No, no, oh my gosh, Kate Martinez, please. It could be, I could probably like just could have gone over it too as well. But, yeah, definitely going forward, I definitely will. I love going to talk more about like, or explaining my rationale as well too. So, yeah, let's definitely like peer program on this together. For sure, not options. I've never heard of options as a HTTP method, and let me know if it is, because I should probably read on it, but I don't think it is a method. I know that get, post, patch, put, delete. So get and post, and I'm gonna say post because post is definitely when you are creating. Let me know if other people have other options of whether A, B, C, or D. A, B, C, or D. So let me know what your thoughts are. Alright, go ahead and put in that answer. We're gonna do post. Okay. So it's correct because post is designed for submitting data to a specified resource, causing a change in state or the creation of a new subordinate resource. The fun thing about post is it's not idempotent. Yeah, K Martinez, I was thinking the same thing too as well. And also, post method is not idempotent. So idempotent basically saying no matter what happens, it would only create just one output. I don't think head is an HTTP method. Is head an HTTP method? I think that's for like your body request. It is. Oh my gosh. I've never heard of it. Works exactly like a GET request, but with one major difference: the server does not return the response body. Interesting. It works like a GET, but it doesn't return a response body. Because with GET, you get the response body so that you can go ahead and be able to display it. So when an AI agent needs to retrieve information from a public database to ground its response, which HTTP method should it typically use? I think about like retrieving information. I think like what throws me off is to ground its response. I'm not sure what that means, but when you talk about retrieving information from a public database, I'm thinking of just GET. Patch is like updating, put is updating as well. Yeah, I'm glad you did as well. I didn't even know there was one. That makes me curious. That is options, because they had options. Oh, it is an HTTP method. I don't work with that enough then. So it's used by the client like a web browser to request information about the communication options available. It acts as a way for the client to ask the server, what action capabilities do you support here? That's so interesting. I've never heard of that. Yeah, let me know if you guys agree with me on this one too as well. Would it be git, patch, delete, or put? I definitely don't think it's patch or put. Patch and put is definitely more for updating. Let me see if I can remember it. Put is updating the whole entire object that you're updating. Patch is just updating like one part of the whole body. delete is saying, hey, let's go ahead and delete this, remove it, get rid of it. So I'm gonna go with get. Let me know what your thoughts are. Alright. Get those answers in. 3, 2, 1. Okay, it is get to strictly retrieve data from a server without modifying the state of the resource, making it the standard choice. I'm glad you do. Okay, let's do another one. Why are REST APIs considered a fundamental component of AI agent architecture? They allow the LM to process tokens way faster during inference. They enable the agent to access a wide range of external data. They are required for fine-tuning process of open weights model. They provide the native mechanism for managing model temperature and frequency penalties. I don't think, from what I know about REST APIs, it's how you're gonna go ahead and retrieve data from other sources. So I don't think it has anything to do with processing tokens. It's more about how to get data. And that's why I feel like B is the right choice. They're required for the fine-tuning process of open weight. I don't think so. With REST APIs, I don't think so. And providing the native mechanism. Yeah, okay. Perfect. We're both going to B. Awesome. You're not AI agents professionals, right? So, option 2 is correct because REST APIs decouple the agent's logic from its data sources, allowing developers to integrate. Yeah, that's what I was thinking. Yeah, I was gonna say unless it's changed, but from what I know about REST APIs, I don't think it had anything to do with like the logic there. I know, okay, Martinez, we're doing great stuff so far. Okay. In the lifecycle of an AI agent, how does tool invocation interact with REST APIs? Okay, I'm gonna need your help here a little bit. I haven't heard about tools yet. So REST APIs are used for internal. The API call is used to replace the agent's prompt engineering strategy. In the lifecycle, how does tool invocation interact? REST APIs are used only for internal communication. The agent invokes in it to perform an action. Okay, so when I think about like lifecycle of an AI agent in tools, when I think about like, because AI has reasoning and it also has, that's like the brain, but the body has the power to go ahead and work on tools, like saying, hey, we're gonna give you a drill and you're gonna go and figure this part out. So if we're talking about tools, we're telling the agent that it can go ahead and invoke an external API to perform an action. I'm gonna go with C. The agent uses REST APIs to compress. No, I'm gonna go with C. I feel strongly with C because anything with APIs is about like being able to retrieve data, talk to external data. Oh, thank you. Oh my gosh. I was like, does that make sense to say drill? I appreciate you saying that. I'm glad that it makes sense. Would you go with C as well, K Martinez? We did it. Okay, so it's correct because tool invocation is a mechanism by which an agent bridges it reasoning with acting, using REST APIs to perform concrete operations like sending emails, updating databases, or executing code. Yes. Okay, let's go number 6. Which characteristic of REST APIs makes them suitable for integration with AI agent? Which characteristic of them? They require a persistent stateful TCP connection for all agent sessions. They are exclusively used for streaming token responses. They provide a scalable architectural style. The only function is the agent is running on a local desktop environment. For sure not local desktop environment. I don't think you need to be on a local desktop environment to go ahead and run this. They provide a scalable architectural style for network. I'm gonna say between A or C. They're exclusively used for streaming token responses. I don't REST APIs, from what I understand, it doesn't have anything much to do with token responses. So let me know if you know otherwise as well. They require a persistent. I'm gonna say TCP connection because I've started learning a little bit about system design. And TCP connection is a way to guarantee is a way to go ahead and guarantee everything is sent in order and secured over the wire so they can talk. Oh no! I was gonna say between this or this is correct because the stateless nature and standard resource-based architecture provide a consistent, predictable interface for agents to interact with diverse systems instead of the underlying. I see. Yeah, I didn't know too much. Okay, no, but that's good to know. So if an AI agent receives a 404 status code from Nextdoor, what does that indicate? Has reached its token limit, is currently processing, resource cannot be found, agent is unauthorized. If it was a 401, it would state unauthorized. 404 definitely means an error, that something didn't work out. Definitely not reaching token limit. Well, thank you, Zifa. Let me know if I pronounced that correctly. But thank you for hanging out. Yes, I was gonna say C because typically 404 it means that it can't be found. Yes, not found error is a standard REST response. Okay, let's go ahead and work on 8. So when designing an agent to interact with an external API, what is the significance of API's documentation? When designing an agent to interact, what is the significance of APIs? Okay, so when you design the agent to interact with the external API, what's the significance of the API's documentation? It provides the weights. I don't think API's documentation will provide weights, so I'm going to say no to the A. It defines the context window size of the agent. I don't think we care about a context window size that I know of, so it's not that. It defines the expected endpoints, request methods, and data schemas required. I'm going to say this thus far. Determines the token-based pricing. I don't think API's documentation dictates token pricing, so I'm going to say C as well. Correct is correct because successful tool invocation requires the agent to understand exactly what parameters an API can expect. This documentation acts as its instruction manual. Very helpful. No, I have to type it? Okay, we're gonna do our best here. So what is the distinction between data retrieval and system interaction when an AI agent utilizes a REST API? This is a good question. Hold up a second. Thank you for hanging on. Hi, I'm doing well, thank you. How are you? We are working on roadmap.sh onto agents, AI agents right now, and we're taking the REST API knowledge quiz. in order for us to go ahead and progress into learning some fundamentals. I think this is good stuff for what this day and age is doing, and I think it's good to go ahead and learn like how we can go ahead and work with AI more with our projects. Okay, anybody want to take a stab at it with me? So think about this as like a pair programming. So any answer, anything you guys have would be great as well. The distinction between data retrieval and system interaction. Okay. When an AI agent utilizes a REST API via data retrieval, it is obtaining information from another system, while system interaction is communicating. Because one thing because the way I think about data retrieval is like you're getting information. If you're thinking about system interaction, hey, like we're talking back and forth, is the vibe I'm getting from it. So let me know what your thoughts are if you're thinking about something else as well. But this is what I'm thinking. Oh yeah, I definitely think it could be improved. So data retrieval specifically refers to using the get method. System interaction, I knew that. System interactions means everything else but the get. Anything state changing. I knew that. I am gonna Anki this into my list. It seems like data retrieval is not an instance a system interaction. Oops. Retrieval. I know, it's good to know, right, K Martinez? I didn't realize utilizes a REST. Refers to the HTTP GET method. Oh, that's good to know. Okay. Explain why the statelessness nature of REST APIs is advantageous for AI agents that operate with the reason or a loop architecture. When I think about like from system design, when you think about stateful versus statelessness, it's usually in reference into memory. Like I want you to remember certain things. I think about like memory. Let me know if you guys are thinking about that too, because I'm trying to think about like the statelessness nature. And when I think about statelessness nature, is like there's no memory, no recollection of anything before or after. Let me know if that's what you guys are thinking as well. It is how would I phrase this? That's what I'm thinking. Ah, your answer misses the core benefit of scalability and fault tolerance. Statelessness advantages. I did not know that. Have you used it before? Z-Free? I hope I said your name right. But have you used it before? Because that sounds pretty cool. I do like it when, because I know that when I use like Because when I use like ChatGPT or other places, sometimes it's a lot to go ahead and retype everything, and I'm like, man, I wish you like could recall from our previous conversations that we've had. I will be saving this for. Let me go ahead and just add it quickly here. Because this. Core benefit. Scalability. No, that is good stuff. We were almost there. We were almost there. Okay. So if an agent is designed to update a user's profile stored in an external system, which HTTP method should you use for a partial update of their user's information? Anybody know? Definitely not get, because that means, hey, we're retrieving the information, not post. Post is a full create, so it's either between put or patch. Which one are you guys putting your monies on? I see. You know, I do like cloud models. I found it to be a little bit more exact and precise. Yeah, I'm gonna say patch, because the difference. I'm gonna say patch. I think it's patch because when I think about like patch, I think about like repairing just like a small piece of clothes packed back together. Um, Really, you guys are gonna say put? Cause like we're thinking about partial update. I think put is a full everything update. I think if we're just looking for partial, like a small piece of like the name or something like that, just one line that needs one update, I'm gonna do patch. And it was patch. Cause yeah, when I think about patch, I think about like stitching up like a piece of cloth together. So you're just fixing that little small piece in your big pile of clothes, and in your like jeans. Cause it's just your pocket that needs to go ahead and get fixed. So you're just fixing the small little piece. So that's why I think about patch like that. I did? Yes, it worked. Okay, good. Because, yeah, put is typically replacing the entire resource. Yeah, all of it. Not bad. Okay, so you do have a solid. So, you guys, we all have a solid grasp of our REST API fundamentals and the practical application in AI agent architecture. So, to reach the next level, let's focus on mastering architectural concepts like statelessness and the precise distinction between various HTTP state changing methods. No, that's good to know. 7273, not too shabby. So let's go and work on our first fundamental, understanding token generation latency. It is a lot to read, but let's do, maybe we'll read it and then we'll take some quizzes as well. Let me move myself. I think I'm blocking you. Oops. There we go. Okay, so understanding token generation latency. So, token generation latency is a duration between a client sending a prompt to a large language model and the model producing the first token of its output. Unlike traditional web services where the server performs a database query and it returns a complete JSON object, LLMs are autoregressive. They predict the next token based on all preceding ones. So they predict the next tokens based off of the previous conversations that they had. Consequently, the time it takes to think scales linearly. Yes, K Martinez, down here, it'll also say test my knowledge. So after, I don't think it's too bad to read this far. Then we'll go ahead and test our knowledge. What do you think about that? We'll read, because we're right here already. And then now we're going to go ahead and test our knowledge. What do you think about that? So the anatomy of the weight. When an application invokes... Oh my gosh. Me too, K Martinez. Me too. No, because that's why I totally understand you. I like to go ahead and quiz myself or be able to reiterate what was that paragraph trying to tell me in my own words. So I feel the same way, K Martinez. So the anatomy of the weight. When an application invokes an LLM, the request traverses a pipeline of heavy computation. So the model must first process your entire input prompt, the prefill phase, before it could begin predicting the initial token. It does. I do agree. Like, having this picture helps a lot. So the client is going to go ahead and create the prompt, and it's going to click pose, create it. API gateway goes here, and then it's going to go into the prompt, go to the model engine, generate its first token, and then first token gets delivered. The time from the request reaching the engine to the delivery of the first token is it's called the time to first token, TTFT. Interesting. This phase is compute intensive because the model must calculate the attention scores for every token in your input prompts simultaneously. If your prompt is long, such as a large PDF or a complex system instruction, the pre-fill time increases significantly, delaying the first token even further. Quantifying. Yeah. Yeah. Read all of that. Once the pre-fill phase is complete, the model enters the decoding phase. Here, the latency is governed by the speed at which the hardware can perform individual inference passes, because each new token relies on the output of the previous one. The process cannot be fully parallelized across multiple tokens. So pre-fill is based on input prompt size. The bottleneck is the memory. When you decode it, sorry, is this helping? Am I in the right area? When you decode it, it's the per token inference. Memory latency. Okay, let me know if this helps. Because in a standard REST-like implementation on stream, the application waits for the entire sequence to be generated before it receives a single byte of data. This means the total waiting time for the user is the sum of the pre-fill time and the time required to generate every single token. If you treat an LLM, the impact of architecture and latency. If you treat an LLM like a traditional API, waiting for the HTTP response body to fully close before displaying content, you effectively hide the progress of the model from the user. You're essentially asking the user to wait for the cumulative duration of all inference cycles before they see any feedback. Streaming changes this by decoupling the completion of the model's work from the delivery of the response. By shifting to a chunked transfer encoding, the model pushes tokens as they are generating, allowing the interface to update in real time. This doesn't make the model faster at processing, but it makes the application proceed as faster by providing immediate visual feedback. Understanding how this latency manifests is the next first step towards managing the user's perception of responsiveness. I see, because sometimes when you see like ChatGPT or Claude talking, you'll see them like you'll see it start spinning, and it'll start writing out like bits and bits by pieces. Having that chunk does make it make you feel like it's thinking, and something's happening and something's occurring. That makes sense. So token generation latency consists of a mender. Yeah, so the way I understand it, so please feel free. No worry. Yeah, well, I would love to know first before I try to paraphrase it in my own words. I would love to know what you understood out of it, just to make sure that like I don't, um, just to make sure that I just don't double on top of what you are going to state already. Let me know what you gather from it. Yeah, so AI tools I use daily is definitely for sure some Claude, some ChatGPT, for sure. So a little bit of those. I used to be a fan of DeepSeek, but I've strayed away from DeepSeek. No particular reason, just I stopped gravitating towards it. So the way I would paraphrase this is from reading all of this information, this whole entire paragraph. What I understood from it is that um, I do have some projects in mind. I do, because I know that AI agents are really good that for to go ahead and help you clean out your email inboxes, or to go ahead and help you like research something. You can go ahead and send off an AI agent to go ahead and run off and go and research something, come back to you later about it. I want to see. I've been working on a project where an AI agent will go ahead and go out and fetch me some job applications. Cause yeah, I am looking for my first role. So if you know of anything, let me know. But I am looking for my first role. So I'm using an AI agent to go out and fetch me some roles, and it's gonna go ahead and show me some roles after it's done fetching it, and it's gonna go ahead and grade it to see like how I fit accordingly to it, and it's gonna go ahead and show me a list of the projects. I don't have it open right now, but I was gonna show you my dashboard for it. But and then it's gonna go ahead and go out to hunter.io and find me contacts, and it's gonna say, hey, I found this person who works at so and so company, and they would be a great contact for you to go ahead and reach out to know more about the role. And so that's what I'm having it do for me right now, because I don't know if you guys are been job hunting lately. Really? I haven't seen roles listed with like within the company or other streamers streaming roles. But let me know. But yeah, um because I know that searching for jobs is just is tedious, and it's like a daily it's definitely like an 8-hour work, but I'm finding ways to go ahead and shorten it on my end. So yeah. But I think this summary is a good way to paraphrase it. So token generation latency consists of mandatory prefill phase and a serial decoding phase, both of which are heavily influenced by prompt size. So it matters by the prompt size of your input and the hardware that you're working on. Because LMs generate content iteratively, the choice between waiting for a complete payload or consuming partial chunks dictates the user experience. Let's test our knowledge. All right. A, B, C, or D? So the definition of a token generation latency is a time to receive a complete JSON object from an API. The duration, we didn't talk in regards to a JSON object, so I'm not going to, for sure not A. The duration between sending a prompt and the model producing the first token, the total time elapsed during a database query in a web service, the time required for a user to read the generated output. It's going to be doing B or D. The duration between definition token generation latency between sending a prompt and the model producing the first token. Might say B. I was gonna say B as well. Answer all questions. Okay. It won't let you answer one by one, so we'll have to come back to it. Thank you, Z-Free. Yeah, no, I got it working and got it going a little bit there, but I hope to talk more about it. I hope you guys think it's like, well, I think it's a cool project, so I think it helps me, like, save time on looking for people. That's true, Game Martinez. That's true. Okay, so what is the pre-fill phase? It is a compute intensive between attention scores for every prompt token calculated simultaneously. It is a stage where the model generates the final token. It involves transferring the model weights from storage to cache. It is a parallelized process that depends on the number of tokens. When I think about pre-fill, I think about like, hey, this is done before so pre-fill, and the pre-fill phase is basically saying like we're gonna start filling this up, and pre-fill phase is typically like, what is the right word I'm looking for? Pre-fill phase is like putting in a prompt or putting in the PDF that you wanted to go ahead and read. That's what I'm thinking of, but none of these speaks in regards to that. It is the stage where the model generates the final token. It does not about the final token. It involves transferring the model weights from storage to cache. We didn't read anything in regards to storage to cache, so for sure not B or C. It is a parallelized process that depends on the number of tokens in the final output. It is compute intensive because attention scores for every prompt token are calculated simultaneously. It is compute intensive. A or D? It is compute intensive pre-fill phase. I might say D. It is a parallels process. Let me know what your thoughts are. So decoding phase bottlenecks. The primary bottleneck is the size of the input prompt. The primary bottleneck is the network latency of the API gateway, memory and latency due to the needs for weights transfer, total numbers of users accessing the model. I think I remember reading more about the initial input prompt. Nothing about the network latency. I don't think we talked about weights transfer, and also we didn't discuss anything about number of users accessing the model. So I'm gonna say A. Let me know if anybody has any other thoughts. So comparing pre-fill and decoding dependency. Prefill is dependent on per token. Prefill is dependent on input prompt size. Decoding is dependent on... I'm going to say this because prefill is all about input. Prefill is like saying, hey, before everything happens, so decoding is dependent on the per token inference. Impact of autoregressive generation. It allows the user to compute the entire response in parallel. Requires to know this. It requires the model to know about the last token to be able to predict the next token. So unstreamed response drawbacks. It allows the user to see real-time updates. I don't think it does. It allows the application to process tokens before. Hides the progress of the model until every entire... I'm going to say C. That's why you can see out little chunks. The effect of streaming on latency. It makes the model physically faster. It eliminates the need for a prefill phase. It improves perceived responsiveness by providing. I think the effect of streaming is about perceived responsiveness. The decoding process allows for parallel generation of multiple tokens. I don't think we discussed anything about multiple tokens. Each new token relies on the output of the previous one, which is true. Decoding is entirely dependent on the prefill phase from memory. Nope, I don't think decoding is dependent. Occurs. I'm going to say currently dependent. Factors, I think we talked about this. Factors influencing TTFT. The speed of the internet's connection. No, I don't think we talked about internet connection. Size of the input prompt. Yes, that was an impact. The total number of tokens requested. The number of times the model has been restarted. Only thing that I remember recalling reading is the size of the input. Why prefill is compute intensive. Model calculates tokens for every token in the prompt at the same time. The model must perform a database query for each individual token. It's not a database query because we're not looking into the database at all for anything. The model waits for the client to send additional tokens. The client doesn't send any token that I'm aware of. The model must convert the entire input into a JSON object before starting. I don't think it does, so I am gonna go with that. Yeah, 6 out of 10. Okay, so we did get that right. It is a compute intensive because attention scores. Now we understand the prefill phase is all about the intention scores. Oh, it was about weights transfer. Comparing prefill is about the input prompt size. Decoding is based on per token. It forces the model, the impact based on all preceding one, forces the model to predict. That is my fault on that one. On stream, it hides the progress of the model into the effect of streaming. Decoding process, each new token relies on the output. The size of the input prompt. Okay. Oh my goodness, we learned a lot today about AI agents. I mean, there's definitely more to go ahead and discuss and talk about. But yeah, I am actually going to go grab some dinner. So thank you for coming to hang out with me. We'll have to do this more, and we'll do some more learning about AI agents more to come. So hope you guys have a great rest of your Saturday. We'll talk some more. Thank you for coming hang out with me too, by the way. Appreciate you guys.